All right, so we've got this question here. It says a dealer finds that sales of a certain item are closely linked to the price he asks per item. If he asks X dollars per item, then he can expect to sell 600 minus 50X items. Each item costs him $5. How much must he ask per item to maximize his total profit? Okay, so this question is all about profit maximization. So there are two ways you can solve this question. Okay, I'll start with the economics way, and then I also do it with the purely mathematics way. All right. So we have to get our information for the question. We're talking about profit here, so we're dealing with revenue and costs. All right. So for revenue, we start with our revenue, total revenue. Okay. Colleagues, how do we get the total revenue of something? How do we get the total revenue? We start opening up our minds here. We multiply price times quantity. Okay. Multiply price times quantity. What's the price in this case here? The price is X. Okay, because they've told us he asks for X dollars per item, so that's the selling price. Our quantity in this case here is this 600 minus 50 X items. Okay, that is our quantity. So Q, replace it with 600 minus 50X. Okay. Any questions before I move further? We're going to move at a slow pace. Okay, do not worry, colleagues. We're moving slow. I won't move fast so that everyone. We're trying to find the selling price to maximize his profit. So remember, profit deals with revenue and costs. Okay. So first thing you need to do first, find the total revenue. Then you find the total cost. Okay. So here to get our total revenue, we just expand this. So this is going to be X times 600, 600X, X times negative 50X, you get negative 50X squared. Okay, this is our total revenue. Next, before we go to the total cost, any questions? Okay, total cost is basically your cost per unit. Multiplied by the quantity. Okay. Here in this question, they told us our cost per unit is $5. Our quantity is 600 minus 50X. Okay. So you can say 5 times 600, that is 3,000. 5 times negative 50X, you get negative 250X. Uh-huh. X is the selling price. Yes, he asks for X dollars per item. So that's the selling price per unit. Any other questions? Okay, so we're going to start with it, the economics way of doing this. Although both ways are still mathematics, but you see this usually in economics, okay? In economics, write this down. In economics, the point of profit maximization occurs where the marginal revenue okay. The point of profit maximization, okay, occurs where marginal revenue, I'll explain what marginal revenue is, equals marginal cost. Okay, that's the point of profit maximization. Okay, where marginal revenue equals marginal cost. What I mean by marginal revenue, marginal revenue is the additional revenue. Let me type this down. Okay, in economics, when you hear the word marginal, it's just additional. Okay, whenever you hear marginal, just equate it to addition. So marginal revenue is the additional revenue you get when you sell an extra good. Okay, that is marginal revenue. So that's the additional revenue if you sell an extra good. Then marginal cost is the additional cost you incur when you produce an extra good. Okay, that's what marginal revenue and marginal cost are. They're just there. Marginal revenue, additional revenue. Marginal cost, additional cost. When it's either you're selling or producing an extra good. Now, mathematically, the marginal revenue is the first derivative of total revenue. Okay. The marginal revenue is the first derivative of the total revenue. And the marginal cost is the first derivative of the total cost. So what's going to happen here, colleagues, is you're going to have to derive this total marginal revenue, additional revenue you get when you sell an extra good. When you, oh, it's the derivative of the total revenue. Okay, marginal revenue is the derivative of the total revenue. Then marginal cost is the derivative of total cost. So in simple terms, what I'm saying is we need to derive our total revenue function and our total cost function. Okay, we need to derive both of these. And I believe we remember how to derive. So colleagues, can we derive our total revenue function? This 600x minus 50x squared, can we derive it? So in the exam, this is how you're going to put it. D T R, you're deriving the total revenue function with respect to X. Okay, this is how you have to put it to show that I'm deriving this total revenue function with respect to X. Yes. So colleagues, when we derive this function, what do we get? Have we forgotten how to derive? Mr. Foster, Mr. Kwam, yes? Yes. 600 minus 100x. Okay. For those who have forgotten, remember exponent, multiply it with the coefficient. 1 times 600, 600. Then you subtract a 1 from the exponent. 1 minus 1, 0. That's why we got the 600 here. 50x squared, exponent 2 times negative 50, negative 100. Subtract a 1, it remains as 100x. Any questions before we derive? Mhm. Madam, remember we expanded this. Remember we said total revenue is P times Q. So we just multiplied x times 600 and x times negative 50x. Is that okay, madam? That's where the x is coming from. Yes, that's where the x is coming from. Okay. With these questions, you have to really pay attention to the wordings, okay? Okay. Can we derive the total cost? Because the marginal cost is the derivative of the total cost. So you write it like this: DTC, you're deriving the total cost function with respect to x. And when we derive the total cost, what do we get when we derive the total cost? Yes, negative 250. Negative 250. Okay. So with this method, okay, first you get your total revenue function. Then you get your total cost function. Once you got your total revenue and your total cost function, you derive both functions as we have done. Okay. Then after you've derived your functions, you equate marginal revenue to marginal cost, meaning this 600 minus 100x, this is our marginal revenue. You put it here, 600 minus 100x equals marginal cost negative 250. Then we solve for x. Grouping like terms, this negative 250 is going to cross over the equal sign, so it's going to become 600 plus 250 equals, this negative 100x crosses over the equal sign, becomes positive 100x. 600 plus 250, 850 divided by 100x. To get the value of x, divide by both sides by 100. 850 divided by 100, $8.5. So basically, for this firm, if they want to maximize revenue, they must sell each good at $8.5. Any questions? So we do not want the, we do, huh? Uh-huh. Yeah, yes. But why would you want to do that? Oh, you felt the swapping was too much. Okay. No, you can do it like that. But then when you get your values, multiply them by -1. Yeah. You get, yeah, mathematics colleagues. There are many ways to do these problems. Okay, many ways. Okay. Yeah, just uh-huh. Mm-hmm. Okay. Okay. No, yeah, as I said, you can do it that way, you can do it this way. Whichever, remember, whatever makes you feel comfortable, okay? In maths, there is no one way to do things, okay? So, yeah. Any questions before we look at the other method? So you choose, sir, we're comfortable with that method and not the other method. Yes, this is the economics way. Yes. You are going to see once you reach, especially market structures in economics, you're going to see this being referred to a lot, the point of profit maximization. Yes. Okay, the second way to do it, you can just say, after you get your total revenue and your total cost function, because you're going to, this total revenue and total cost function is going to be applicable in both ways. Okay. So after you go to your total revenue and your total cost function, remember profit equals total revenue minus total cost. Okay, so you're going to say total revenue 600 minus 50x squared minus total cost. What's the total cost? 3,000 minus 250x. First thing you need to do, you need to distribute this negative sign, okay? Colleagues, every time if you see a negative sign before a bracket with terms in it, always distribute the negative sign, okay? Don't just take it as, oh, it's just minus 3,000 minus 250x. No. So you say negative 1 times 3,000, negative 3,000, negative 1 times negative 250x, you get positive 250x. And here we have our 600x minus 50x squared. All right, we have like terms here. Okay, so we add like terms. Okay, so this 600x plus 250, you get 850x. So we have to rewrite our quadratic equation, negative 50 x squared plus 600 plus 250x, that's 850x. Minus 3,000. Okay, so we have a quadratic equation here. Okay, this is a quadratic equation because of what? X squared. So according to the principles of quadratic equations, when your leading coefficient, your a value, if it's negative, meaning it's less than 0, it means a quadratic equation is in this form here, an upside down parabola or parabola. I don't know, whichever you like to hear. I prefer calling it a parabola. Okay, so with a parabola, you have your maximum point here. And with your maximum point, you can get your x value and your y value. How do you get the maximum, the x value for the maximum point? This is the formula. X equals negative b over 2a. So here in this case here, our b is 850. So you put negative 850 there. Our a is negative 50. So you say 2 times negative 50. So you say negative 850 over 2 times negative 50, that's negative 100. Negative 850 divided by negative 100, you get 8.5. So you say x equals 8.5, meaning this person should charge $8.5 for his good. Any questions? Yes. This one here. It's for yes, it's for quadratic equations. Yes. Quadra- quadratic colleagues, quadratic equations. Quadratic equations, colleagues. There's a lot about them. Okay. This topic, if you have a grade 12 book at home, okay. If you've got what's this book? Progress. Yes, Progress grade 11. If you've got children who are doing grade 11, okay, just go, you'll see on quadratic functions. There's a topic quadratic functions there. You'll see these formulae there. How to find the maximum and the minimum, the coordinates for the maximum point of a quadratic equation. How to find also the minimum point for the points of a quadratic equation. So, madam, there are a lot of formulae for quadratic equations. You've got the discriminant, you've got the quadratic formula. Okay, there are even the roots of quadratic equations, which we're going to see later on. So there's a lot on quadratic equations. Okay. Yes. Any questions? Or you thought I've just made up this formula? Yes. So, colleagues, which one do we prefer? The pure maths way or the economics way? You're quick to say that. Oh, okay. Okay, now I understand where you're coming from. Yes. Um, yes. How can I put it? Maybe there'll be a day I'll walk you through these quadratic equations and the important points you need to understand for them. Because even to use yes, and even to use this method, basically you have to have an understanding of quadratic equations. If you don't have an understanding, you find it will be kind of difficult. But you only use this way if you come up with a quadratic equation. If you find it's a polynomial equation, let's go x to the power 1. I've just forgotten how you deal with it in that case. The rules will change.